Welcome everyone to Generative AI in Enterprise. This is our ninth episode. I casually started this group back in December. Every day I see like more and more people interested. Not only that, I find so many interesting things happening. And if I reach out to someone and say, hey, I found this fantastic thing that you're working on. Do you want to share or your experience? Everyone share their experience and knowledge among us. So that is the beauty of collaboration, and that is the beauty of learning from each other, right? So here we are today on a Thursday night with a group of people who are interested to know what's happening in this new area of generative AI. The topic is TunedIn. TunedIn is a startup founded by a group of undergrad students,
Okay.
University of Illinois, Urbana-Champaign. And I believe Manit, your friends are also from the same school. Manit Niwas is our key speaker today. Manit is working in 2 degrees right now, computer science and statistics. Manit is actually my neighbor. And we are all from the same community, Plainsboro. Manit loves to compete in triathlons, and also Manit is interested in technology to sports and also to news. And that's where kind of like the whole inspiration of creating TuneIn started. So, being said that, we all would like to hear from Manit. First of all, what is your inspiration of building a startup? And then what do the technology which is going behind the scenes, and then how do you want to scale it up, the infrastructure architecture? Of course, like you do not have to tell your trade secrets and all. You keep it your special secret sauce to yourself. That's fine. But more importantly, give us a little bit of insight about like what is the infrastructure, what is the scalability options, and also maybe the future of TuneIn. Like how do you want to scale up, generate funds, and how do you want to make money out of it? How is it even possible? And we have so many, who are your competitors? There are so many questions that can come up. So this particular episode is not only about the generative AI technology, but it's going to be much more. So I'm going to open up the conversation with a very quick introduction to some of our standard stuff. So this is our agenda. This recording will be available in Curious Circuits YouTube channel. And this whole meetup that I'm doing is not sponsored by my employer. It's all my personal interest. Microphone, I'm going to purposefully keep everyone on mute because we had several Zoom bombing scenarios last couple of weeks. So I'm going to put everyone on mute. If you have to ask a question, put it in the chat window. We'll do the best to answer the questions. Camera is optional, but we would love to see you. So please try to keep your camera on. And then Manit, over to you. Tune in.
Sure. Thank you so much. My name is Manit. I'm here with the rest of my team. We've all founded this company together called TunedIn. Could I actually start sharing some slides?
Yeah, please.
Yeah, I'll just take a moment to introduce the company, and then we'll all share the floor. But our company TunedIn, we'll talk a little bit about it. We're here to deliver personalized podcasts straight to you. Just a little introduction of who we are before we dive in. My name is Maya. We're all juniors from the University of Illinois Urbana-Champaign studying computer science. Specifically, I've been focusing a lot on the marketing and front end side of things. I'll let everyone else introduce themselves and kind of what they've been working on too.
So I can introduce myself here. Hi, I'm Rohan. I'm also one of the co-founders of TunedIn, like everyone else here. I'm also a junior here at UIUC studying computer science, and I'm excited to be here introducing TunedIn to all of you. So.
Hi, I'm Sophia. I'm also a junior studying computer science and chemistry. I'm working on the front end, and I'm excited to share what we're doing.
Hi, my name is Vansh. I'm also a junior studying computer science. Really excited about some of the progress we made on the tech side, which we will definitely talk about later. Yeah, excited to be here.
I'm Varun, like Vanch. I'm also junior, and I'm working mainly on some of the backend stuff, like searching for content and yeah, that type of thing.
And I'm Sumay. I'm also a junior studying computer science at UIUC. And me and Vansh have primarily been focusing on the text-to-speech side, so a bit more on the AI side of the product. And yeah, I'm really excited to be here and talk a bit more about TunedIn.
Yeah, so just to give a little, oh, sorry, did I interrupt anyone?
I know.
Just to give a little structure of what the presentation will look like, we're going to talk mainly about the architecture, how we're building this product, what goes on from when you actually input your preferences into the app all the way to the final product that you get, the podcast. If there are any questions about the business aspect, how we're going to scale, grow, how we started, we're more than happy to answer those at the end.
Cool. So I guess before we go a bit deeper into the product, I just want to just talk about our mission. So our mission is we want to enable everyone in the world to be able to be informed and entertained about anything, anywhere, anytime.
And yeah, so the problem we're trying to solve is that we believe that current content that people are consuming just isn't meeting the standards that we want them to. For example, one of the problems that we see nowadays is endless scrolling with apps like TikTok, Instagram Reels. And yeah, those sort of apps, people just get caught scrolling and just not seeing a lot of useful content that betters them. And we also notice that a lot of content that is being served to them doesn't necessarily relate to their interests. And seeing a post that you're genuinely interested in is pretty rare. And another problem with today's content is that there is a limited supply. Like you can only see content that other people post. There's no content being generated that's just for them. You're just basically relying on someone else to post what you're interested in. And finally, the ease of consumption aspect of it. Like there's so much content out there and it's just hard to consume it all. So we believe that a problem is that this content needs to be like in a more uniform fashion, just easy to be consumed, which is kind of why we went towards this audio format as well. Like we're targeting people that are really busy and just want to listen to something on the go. So yeah.
Yeah, building off of what Varun said, we surveyed a bunch of people and people definitely agree with these problems. Over 50% of these people don't really feel up to date with their interests, especially those that have like really, really niche interests that aren't so mainstream. 44% of these Americans have said that like their main obstacle in obtaining like this new information, this news, is lack of time. And so we're trying to solve that with TunedIn as well. Interestingly enough, around 45% of 18 to 25-year-olds actually get their news from social media and not traditional news. So we believe like an app format will also kind of offset this problem and help it. And furthermore, the audio content industry, including podcasting, is growing about 40% every year. So people want a more flexible and digestible way to consume their content.
A bit into where we see ourselves on like the historical delivery of news. Back in like the 1990s, news was mostly delivered in the form of very general content. Big companies would be putting out newspapers, tabloids, ads, and it would be up to users to find what was created by these big companies. It was all like very general since publishing wasn't super duper cheap and accessible. It was mostly just like news generated by big companies and published by them. In the 2010s, however, like with the rise of social media a bit, with it sort of entering the mainstream a bit more, a bunch of like different people were able to post content based on what they want. So a lot more stuff could be published. Like publishing was no longer limited to like the massive companies that were responsible for sending out the news. By following people that like you were interested in on Twitter, you could keep track of the content that they're posting. However, like while this did lead to like a larger spectrum of content being able to be discovered, users still had to find the accounts to follow and like find the different people, find the subreddits, find just a bunch of different sources. And most of the like search for news was centered around like manual searching. Recently, the For You era has really taken foot. TikTok, Instagram, all these big social media sites now take this content that is created by other users and they feed it to you based on what they think you'll like. Because like based on your implicit preferences, based on what you've liked and what you haven't liked, algorithms learn to serve other people's content to you. And making like sort of reducing the friction for you to stay informed a bit more. However, we see ourselves as the next logical step in this, where content isn't created by other users and served to you based on like what people like the algorithm thinks you may like. However, we think that when like you as a user just put down what you are interested in, content should be generated for you, being able to capture all of your interests and not being limited to just what other people have posted and what an algorithm can find for you.
Yeah, absolutely. So given this problem of not being able to search for news in a really easy and accessible way, our solution is to have AI generated podcasts that are based on your specific interests. And what does this really look like? So from a user standpoint, if you put in your interests like politics, news, and sports, for example, you would get a personalized podcast in our app that essentially researches the most current news on these topics and delivers this to you in an audio format. And typically that's 5 to 15 minutes. So below, I have a quick demo on our website. Feel free to check that out. But actually, if we go to the next slide, yeah, so on this slide here, you can see our app, which is currently on the App Store. So feel free to go download that. It's called TunedIn Today. Feel free to download that, play with it as we're kind of doing this presentation, and we'll have a feedback form for you guys at the end. But essentially, what I was talking about is on the right-hand side, the right-hand screenshot here, you can see a screenshot of our app in which you as the user would put different topics in. For example, we have like Tesla, NFL, ESPN here. And then each day you would get a short podcast that kind of summarizes the most recent research on those topics. Yeah, so now we're going to get into a little bit more the technical side of our product and kind of look at how we're doing some of these things that we just outlined. The first step in that is search. So kind of as we mentioned, we take in these different inputs that the user puts in and research those topics. So that's done by kind of getting the latest information using a search engine that we'll talk about in just a minute here. We're also the second step in that is going to be to validate that content that we just got, make sure it's relevant and the sources are correct and not making up any information. And then overall, we want to kind of minimize the amount of searching being done so that, in the searches we are doing, we're being very efficient about how we get that information.
Yeah, so I'll go a bit into how we're actually accomplishing this search. So the first thing that we do when we perform a search on a specific preference is that we find relevant links and articles that we believe would be super important for our users to hear. And the way we do this is using a neural search engine. And basically what a neural search engine is that it uses LLMs and neural networks for a context-aware exploration of the content that's indexed on the web. Unlike keyword search, which relies on the exact match of like whatever you enter into your query, neural search actually delves into the semantics of this query and processes natural language, comprehending like intent and retrieving results that might not contain these keywords, but might still be relevant. And at the heart of this neural search I kind of mentioned is natural language processing. And basically the point of this is that we want to like not only have whatever words are present in the query itself, but we also want to understand the nuances of what the query is like actually trying to say. So when you ask a complex question or present a query in like a super conversational tone, the neural search will first employ NLP to dissect the semantics of this query and figure out its intent. And this basically just results in a search experience that's way more intuitive, engaging, and relevant for our users. And another breakthrough that's happened in neural search is the use of vector embeddings. And embeddings are basically just vector representations of text that capture the meaning of these words in like number format. And by converting this text into numerical form, neural search can more easily perform operations to determine the similarity of like what the intent behind this message is versus what the intent behind like an article that we're comparing it to is. And by analyzing these semantic relationships, we can basically much more efficiently figure out what content is super related to like a preference. And the way that I see it is that basically when you perform like a keyword search, you're just trying to find content that has those words. But when you perform a neural search, it's like you did like hundreds of hours of research on all the sources out there and actually figured out what resources are super relevant to you.
Yeah, so as Varun mentioned, neural search is kind of the first step in what we really do. And a common question we get to is like, hey, why don't you just ask large language models for the most recent news that you might get on a particular topic? For example, why don't you just ask ChatGPT, what happened in the New York Knicks game yesterday? And the reason that we can't really do that is because large language models are trained on information that's years old. So if you ask it for any recent information, it's not really going to give you a correct answer because it doesn't know the correct answer and doesn't have that ability to really search the internet. So that's where the search stage really comes in. And after we do our neural searches on the user topics, we add another large language model layer on top of that to actually validate the sources that we get. What this typically looks like is looking for relevance between, the output of our neural search and what was actually given in. We just want to make sure that, the topics that were put inside are actually relevant to the output we got inside before we actually start building this podcast. On top of that, we want to keep searching until relevant content is actually found. We have a preset amount of content that we typically look for before we decide to kind of proceed from this stage. And usually we keep doing the search until we reach that preset amount.
And I kind of mentioned this when I was talking about neural search, but we also use vector databases for other things. So I'll just give you a quick overview of what a vector-based database actually is. It's basically just a specialized type of database designed to store vector embeddings efficiently. And remember, vector embeddings were basically storing words, text, and like other phrases in a sort of numerical form. And yeah, we basically use these vector databases to compare similarity scores between like different preferences. Like we kind of mentioned on our goal slide, we don't want to like research, we want to like optimize how much research we're actually doing on topics. So for example, if one user types in like US politics and another user types in American politics, we don't want to perform this search twice and sort of like, yeah, call this LLM twice when we can only do it once because these contents are super similar. So what we do is that we compare the embeddings of all our preferences and see if there's any repeat work being done. And if there is repeat work being done, we sort of eliminate it and sort of perform that research only once. And another reason we're using vector databases is to suggest preferences for a user. So like, let's say a user types in a lot of preferences related to sports. On our app, we also show them suggested preferences that we believe they might be interested in. So if a user has a lot of sports-related preferences, this vector database will query whatever other preferences that we have in the database and figure out what's super similar to what the user actually has before. So if they have like basketball, football, they might get a suggested preference being like hockey, something that's similar to what they already have.
The next step, once we already have all the sources, is to make them into actual podcasts by creating scripts. And so some major considerations for making these scripts is the style and making them engaging, which we do by having a conversation between two people. And then we also want to avoid repeated content in the script. If there are two articles with the same content, we want that to all be combined into one. And in sources, we want to check that the sources are correct and kind of have good information and get the best information from the sources put into the script that the users care about. And also with any AI, hallucinations are a problem and consideration. So we want to make sure that the script is actually sticking to the sources that we have and only put weights on topics based on how much news from the last day the topic actually has. So there isn't repeated content again from a couple days ago.
Yep. So how do we actually implement all of these considerations and make sure we're considering those different concerns? One thing that we do is we summarize previous topics and previous queries. So I think Rohan and Varun were talking about this earlier. Say your interest is American politics or US politics. We can summarize a certain query and cache that summarization. So the next day or the next time a user wants to look for US politics or American politics, we can look at that previous summary and search content that is dissimilar to what we've already searched for and presented to the user before. And this helps us, again, reduce repeated content, give some uniqueness and freshness to the actual podcasts. We also provide a large amount of data to our LLM for generating scripts. What we essentially do is with the sources that we have retrieved before, we take the HTML source file of the actual page, strip the HTML syntax out of it so we get just the raw content, and feed that entire raw content into the LLM for all of the sources for a specific topic, as well as give it very specific instructions of the format we want and what we want the LLM to actually do. This helps with two things: one, the quality, and also hallucinations, because by providing the data and telling it specific things of what to do, we can limit the actual amount of interpretation that the LLM does, which is a big concern, not only for just the quality of the product, but also in terms of legal reasons. We don't want to make sure we're inputting any kind of opinion and making sure that it's really just giving a report only. Okay, yeah. One optimization that we do, and this was mentioned a bit earlier, is batching. So if you had the chance to download the app or picked it up from earlier, we say that users can generate a podcast. And for the most part, that can happen in real time. But what we've noticed from surveying different customers and just ourselves is that a lot of users would like to wake up in the morning and have a podcast already there for them that they can listen to on their drive to work or on their walk to class. And so we came up with this optimization of doing batch, where we can group certain topics that are similar in our vector DB. We can prevent requerying and rescripting different topics because they're, or sorry, the same topic for different users. And we can group them all together in a batch process to actually optimize that process. Actually, Rohan, Varun, do you want to talk about a little bit on batch for script or sorry, for sources?
Yeah, I can talk a little bit about that. So, as Manit mentioned, we do generate podcasts in real time, and typically that looks like, you'll put your interest in and then hit generate. Takes about 1 minute and 20 seconds to give you that podcast in real time. But for those who want it ahead of time and ready when they wake up in the morning, we have this idea of batch. And again, the first step with that is doing the search for relevant content. And what we kind of do there is we look at the different topics users have, and if they have the same topic, we want to cache that information that we did for the research. So quick example there is, if Manit has the preference sports and I also have the preference sports, there's no reason for us to call the same search methodology 2 times. Instead, we should just do it once, cache that information, and then when it's ready for my podcast to be made, we can use that same information in both of our podcasts.
Yeah, there are a few questions in the chat, so I think we can just take a minute to address them. This one, I guess, was for you and Varun, Rohan. How are you validating the information that it's correct, and what is the source of truth?
Yeah, I can take this one. So to answer your question, there's really no way to validate if like a given source is correct. We're kind of counting on our neural search engine to respond with the most like relevant results. And the validation that we kind of mentioned before, that's more validation not on the accuracy of the content, but on the relevance of the content. So when I say relevance, like let's say the user's preference on basketball, like a lot of times when you're searching using these like APIs for like Google and stuff, you won't really get information that's super relevant to basketball. So what we're doing when we validate is that we're really just checking if this information is relevant to the preference, because yeah, we're not really doing an accuracy check on that information. We're just counting on the neural search engine to return sources that we believe have accurate information, if that makes sense.
We do use one layer to kind of validate relevancy between the information. Typically, what we count as good and relevant and valid information are reputable sources, right? So if you were to go on the internet and search for a specific topic in the news, you might consider news sources of the Wall Street Journal, New York Times, CNN, MSNBC. Take whatever popular news outlet you feel is necessary, and we count that as correct as, say, a university or a professional in the news industry would consider a correct source to be. So that's typically what we consider valid. Things that would be invalid would more be like, tweets from a given user, scrubbing a Reddit post for someone's personal information versus, a professional in the industry who's actually researched that information. And then we can use that in our podcast. I think I'm going to skip down. I think there was this question about paywalls. Currently, we're not scraping anything that has a paywall on it, and that's just because of copyright reasons. I don't think that that falls within something that's legal to actually scrape something that's behind a paywall and then put it in our podcast for free. So I hope that answers both of those questions.
I can actually piggyback off of that response and answer the second question about intellectual property at the same time. a future feature that we're working on is actually letting you integrate different subscriptions that you have with our application. So say you have a Wall Street Journal subscription, you would like to get news from Wall Street Journal as a source, then you can authenticate with Wall Street Journal or through Wall Street Journal with us, and we would be able to give you content like that. But yes, for the time being, like Rohan was saying, we're not going past any paywalls. We're trying to be as legal as possible. The second question on intellectual property, Sophia, you can also chime in on this, but we are making sure, like Rohan was saying about credible sources, we're also making sure we avoid sources that have some kind of copyright on them where we can't use that information. And we also do some things on the app, if you want to explain, that make sure we're protected.
Yeah, so on the app, we also link to all of our sources that we use. So if a user gets something in their script that they're very interested in and want to read more about, they can always check that out, and we make sure that we give credit to the actual sources.
Yeah, additionally, in our prompt, we tell our two speakers are Greg and Jane. We tell our prompt to make sure Greg and Jane actually refer and cite the sources that they use for the information they present.
And to answer the question just in the chat, we do not use podcast content. It's all news sources that are all text-based. So we're not
to that follow-up question. Yeah, we don't scrub audio sources, only written content. And we don't scrub anything from anyone else's podcast. These are only from like reputable like news outlet sources, if that makes sense.
Yeah. Did you mention stitching scripts, Ron? I forgot.
No, I didn't mention that.
Okay. So on top of batching our search engine, where we just search the same preference or search only one preference once and not multiple times, we also generate the script for that specific preference and store that. So when the user wants to generate a podcast, or if they have it scheduled to be previously generated, what we do is just take the pre-generated scripts for that day and stitch them together either in real time or batch before if you would like your podcast ready beforehand. So it saved generation time, and it also ensures that we're not doing extra work on our end. I think there were no more questions so far, but feel free to ask them in the chat, or if you have a question and you want to just unmute, that's also good with us.
Yeah, so before I get into text-to-speech, I just want to like piggyback off of their points. Everything we do is generative. Everything we do, as in like by personalized podcasts, we mean that you put in your interests and then we search the internet for you. We aggregate that content, make it into a script via LLM, and then use text-to-speech to present it back to you. So yeah, like I was saying, text-to-speech is a very core part of our product. And it actually becomes a business problem because one, we need to generate audio that kind of sticks to the script, and also like you would want to listen to, so you don't click off the app, and then we lose users, and we just make less money in general. And also we need to balance cost and generation quality, because obviously we could like rely very heavily on OpenAI, for example, and be like perfect in our text-to-speech generation, but this costs a lot. Or we could rely on very small scale open source models that have not been like built out very well, and our generation quality kind of takes a hit. But luckily, there are some really, really great open source models that we found that Sumay will talk about right now.
Yeah, sure. So, I mean, before I get into the specifics of the model, just if anyone on this call right now has been involved with the open source community, I just want to give a huge thank you, because without like open source software in general, products like TunedIn just wouldn't be possible, because like with the proliferation of just models getting bigger and bigger, it's a lot more expensive, and like it's just a lot harder for normal people who aren't affiliated with massive companies to be able to get access to like the compute and also like the opportunity and the data to be able to train models good enough to accomplish like tasks like text-to-speech. And without like what open source allows people to do is it allows people who otherwise wouldn't have access or the resources to be able to develop models like this, to really be able to experiment with AI, play around a bit more, and also develop really cool products. So again, like if anybody's been involved in the open source community, big shout out. And now I'll get into Bark. So Bark is one of the open source models that we are using and playing around with a bit. Note that it says it's a text to audio model, not a text to speech model. And what this means is a text-to-speech model, basically what it does, takes in text, outputs speech. A text-to-audio model takes in text, but rather than being limited to just speech, it's able to output all sorts of different kinds of sounds. For instance, like if you want to have like a dog barking, it'll bark like a dog. Or maybe a bit more of like a applicable example, text to audio is able to generate laughs, generate coughs, and just in general be able to generate audio that sounds more human-like than just speech, because we're not limiting what we can generate to just speech. And that adds to a more realistic experience and a more human-like experience in the audio quality that you get out of a model like this. So a bit into how this model works. We start with text. Text gets sent to the model. We use a transformer based on Nano GPT, which is like a smaller version of the very famous GPT architecture that basically uses like the transformer layer and attention to take this text and generate semantic tokens, which are a representation of the text in vector form. These semantic tokens are then passed through another Nano GPT type layer, which generates coarse audio tokens. What coarse audio tokens are is they're like an intermediate layer between the semantic tokens, which are more closely tied to the text, and the fine audio tokens, which are closer to what gets turned directly into waveform audio. So what these coarse audio tokens allow the model to do is it makes the learning process a bit easier, because these coarse audio tokens are actually able to be generated from actual audio and from training data. And having this intermediate step makes this a significantly easier problem for the model to tackle and the model to learn, just because it doesn't have to, like, end-to-end deep learning in general requires a lot of data and it's not always successful. But these intermediate steps in big models, I think this model is about like 500 million parameters or something of the like. So these intermediate steps really make the learning problem a lot more tractable. These coarse audio tokens are then passed through another Nano GPT layer, when we get the fine audio tokens, which is what I talked about before. And then encodec, which is an encoder, or like an audio, like a way to get a bit closer to this waveform audio, something that Vansh will talk about a bit in the next slide, is then applied to these fine audio tokens, and then it's passed through a vocoder after that, which improves the voice quality, and then the waveform audio is generated. So I guess the biggest takeaway from like a model like Bark is just the impact transformers have had on just AI in general, because transformers really allow the embedding of context and being able to really process this sequential input a lot more effectively than prior architectures. So really the transformer is what carries this model to be able to generate very effective sound.
Yeah, so getting into the second model, we want to talk about whisper speech. It's very, very similar to the model that Sumay just described, where we utilize transformers and encodec, but it's a text-to-speech model instead of a text-to-audio model, which means that it's very, very specifically applied to just speech. It's a little bit more limited in its behavior, like we can't generate like coughs as well, or like dogs barking or music in the background, but we can have a bit more predictability in the speech it generates, leading to less hallucinations, which is an issue we'll talk about a bit later. But into the architecture, it has a set of transformer blocks, very, very similar to Bark again, where we generate semantic tokens, coarse audio tokens, and then fine audio tokens. And then we pass it into encodec, which is what Sumay also talked about earlier, but here we have a nice picture of it, which is basically a neural network, kind of working with the encoder-decoder paradigm, where we take in the audio tokens as a waveform, encode it into this thing called a quantizer, which learns latent representations, which is a way of representing these audio waveforms as sort of like a vector that is, I guess, embedded, like an embedded version of these audio waves. And then a decoder, which takes these like quantized embeddings and re-represents them as a waveform. And we pass this re-represented waveform into a discriminator, which tries to tell the difference between the original audio and this new generated audio. And it fine-tunes the neural network in order for the generated audio to be as close to the original audio as possible. And if you look here, we have a different set of L's, which are all loss functions. We compute the loss based on the difference between the spectrogram output, between the difference between the pure audio wave output, and the difference computed in the discriminator. So again, key takeaway here, is that this is a text-to-speech model, very, very similar to Bark. In fact, all open source text-to-speech or text-to-blank models are getting very, very similar, which means we're kind of converging to the state of the art. Yeah, so that's just a little bit about whisper speech.
And adding on a little bit to this, the fact that the models Bark and Whisper Speech are able to be so similar yet produce like very different results, one being text to audio, one being text to speech, just speaks to the real importance of having good data in AI development. Because like with like the goal of an architecture is to be able to learn different patterns that are from data. But eventually architecture is a lot easier to iterate on and make good than data itself. And sort of like from the early days of computer science, it's been known garbage in, garbage out. And this has never been more true than with AI, because with like models like these, the architecture can only take you so far. If you don't have if you don't have great data, getting good results is extremely, extremely difficult. I remember hearing somewhere that OpenAI or OpenAI, or like a lot of people were saying OpenAI's biggest advantage wasn't its model architecture. It was the quality of data that it would get. Like OpenAI is able to access amazing data. I don't really know how. They do a lot of like pre-processing and engineering and stuff that we're not privy to. But data is just like, we just wanted to say, highlight the importance of data in like this in AI, especially with like generative AI applications like this. And
yeah. Oh yeah, go ahead. You can
go.
Okay, yeah. So yeah, just picking back off of that, if we rely too heavily on the data like pre-trained though, and considering that we're taking like samples from like a probability distribution, we can be heavily susceptible to this thing called hallucinations, which is basically where instead of like generating cohesive like speech, kind of like we've been doing throughout this like presentation, it would start saying like garbage. That sounds very, very correct in like the inflections it produces and things like that, but it has no real English comprehensive understanding, which is really, really funny to listen to, but it kind of ruins our product as a whole. So we have to be very, very concerned about this.
Yeah, like about hallucinations, at least. I remember like there have been quite a few times I've been playing with models, and when we hear the outputs, if we're not fully paying attention, we wouldn't realize that what we're getting fed is straight garbage. Like because like all these models, generative models in the end are probabilistic, it is like predicting what's the next likely sound that you're gonna hear. And like this next likely sound is very likely to be something that logically your brain thinks it would make sense. So if you're like unless if you're actually focused, it's very easy to miss these hallucinations, which is like very interesting observation with different models. Another issue that we faced is pronunciation of uncommon words. So like, for example, we had this one case where we were commissioned to read an article and one of the people's names was Piotr. And that's not a very common name in like the training data that any of the models have been given. So the model really struggled to pronounce like a name like that. And in general, that's just a problem with the fact that, again, like the data just doesn't contain like all the words that we're ever going to need. So pronouncing these uncommon words can get a bit difficult. And that's one of the challenges that we faced. And also like these models have been trained on data that has been processed in a certain way. So sometimes even stuff like apostrophe S gets annoying to pronounce for a lot of the models. Like sometimes like when asked to pronounce an apostrophe S, the model just says like the word and then S rather than actually like pronouncing it in plural form. So that's again something that's really speaks to the importance of data, and that's a big challenge that we faced.
Yeah, and then I think on this list, the only architectural problem here is the short context window, which is literally because the transformer itself, the self-attention mechanism it uses, which is how it relates different words to different words and like understands sentence structure, is too small. So by expanding the self-attention mechanism itself and making it more like robust, we can actually get longer context windows. But this is very, very hard to do because it's like a very repetitive menial task for the people building the architecture to do. So this is something that we have to dive into and take on ourselves.
Oh yeah, and another big another two problems that we faced is non-determinism in voice and tone, because like at least because again these models are probabilistic, oftentimes you generate the same thing twice, it's not going to be the same. And I guess tied to the short context windows, when we have to chunk up output, we get sometimes often the speaker sounds different from chunk to chunk. And I guess that's a problem with short context windows that architecture can definitely solve. And again, emotion quality is also a big problem that we faced. It's one of the like biggest areas of research in text to speech, how to make it sound more human-like. And again, this is largely a problem with data, in addition to like maybe there are some a bit like more fine-tuned architecture changes that could be made in order to capture emotions better, but that's a very active and open problem that's being solved right now.
Yeah, so we're going to wrap up in a second, open it up for questions. Just wanted to quickly mention again, like we were saying earlier, we are on the App Store and we are a very early stage, so we are constantly developing. Even at the feedback we've gotten in the chat so far has been really helpful to us in terms of improving our product. So if anyone is interested to help us improve our product or is interested in learning more about this, we can chat after this. We can exchange contacts and be a great way for us to get feedback as well as build a product that's going to be useful to you and anyone else who wants better news consumption.
I have it over here in my phone at least. That's what I can tell you.
Awesome.
Wonderful presentation. Wonderful presentation.
Yeah. Thank
So
you.
you guys are done, right? With your at least presentation point of
Yeah,
view?
yeah. If anyone has questions, we're happy to answer them.
Awesome. Okay. So couple of questions that comes to me or in my mind is like this is of course there is a lot of research that is already happening in this area. And so currently, what do you consider this product as? Is it still in a research mode or is it prod ready, ready for mainstream? It's already in the App Store. I know, like it's already there, but just a general question: is it like ready for mainstream, or do you still think that there is a lot of research that needs to be done?
Yeah, so everyone else can chime in as you want. As far as piecing the parts together, we talked about the different components in our architecture. We've laid out foundation pretty well and have gotten to the point where we can present at least a very good MVP and a good product where we can sustain a decent amount of users. I think we said we had 100 right now, and that number is growing as we're on the App Store. So we are in early stage, but good enough where our app can be used by everyone on this call and other users. Where we could use more work is just improving the quality of the product. So right now, the research phase is more so us iterating back to our previous work and improving the research of sources, our script generation, and even developing our text-to-speech and making sure we're not having those hallucinations, those short context windows, and everything else that we had talked about before. If you guys want to chime in, go ahead.
Yeah, I can just say pretty much everything Manit said was correct. We're still looking at a few different options and a few different features for what people are interested in. That's kind of why I was very excited to come here today and help and be with everyone to present our idea, because your feedback is infinitely valuable to us to kind of see if the direction we're going is interesting and if this is a product that people like you would consider using. So.
Okay. Great. Next question that I have is citations. What about citations? Like typically, if I go to Perplexity or ChatGPT or even now Google Gemini and all, so they'll have citations. With podcast, which is auto-generated, how do I know where is the source coming from? As a consumer, I have the right to understand the source.
Yeah, so we save what our search gets for sources, and then we just use those to create the script in the podcast. And so from the app, you can actually see in your own podcast that you get what sources were used to create it.
Oh, really? Okay.
Go to that and look into it. Yeah.
Oh, okay. Yeah. Somehow I did not notice it, that particular link over there. Now I can see. But it doesn't have the citations, or does it?
If you scroll all the way down.
Okay, I'll check it out. But Prakash, you have a question, so you have raised your hand. Go ahead.
Yeah, hey, I'm impressed. You guys are onto something pretty significant. And clearly, you have command over the technology, which is still in early days, in my view. A couple of things. One is I'm not an Apple user. As much as we have somebody in the family who used to work for Apple, so she recommended we don't use Apple products for whatever reason. Anyway, so I can download your app, unfortunately, but I think this is something good. So on Android, I get by default Flipboard. You're probably familiar with Flipboard. I love Flipboard. because it really right from the get-go, right? I kind of get the information that I need, and I don't remember entering any specific preferences, but over time, obviously, I've had it for a number of years. It kind of gives me a lot of stuff, right? That seems to be relevant. The interesting bit about content that keeps getting pushed to me, which you guys probably know the technology behind it, it seems to hear what we talk about. So 24 hours or within 24 hours, it seems to be listening to what we are talking about, right? In normal conversations within a family. And then within 24 hours or less, it delivers some content that is pertaining to that. It's contextual. So a lot of these products exist. So how are you folks going to first of all differentiate? And are you trying to create something that is equivalent to Flipboard?
I guess two things. I think Varun, since you were looking at Flipboard yesterday, if you want to touch on that part, but maybe how we're different from other competitors. One is we present this in a format. Obviously, text-to-speech isn't anything that's novel, but we take this news and we present it in a format that is a lot more easily digestible than, say, Flipboard or other news aggregators. This is something that you can use when you're in the car. Sorry, go ahead. I just think this is something you
No,
can
I find Flipboard to be very easy to use. So
Flipboard is definitely very easy to use.
Yeah.
But this is something where you can listen to something in the car on the walk to class or walk to work. It's also generated content. Varun, do you want to talk about Flipboard? I don't think that's generated content.
Sure. Yeah. So the way I see our differentiation to a company like Flipboard, so from my understanding, Flipboard serves you articles from like a variety of sources that they believe you're interested in, correct? Yeah. So the way that we see ourselves sort of being different than that is, like we mentioned before, we're still generative content. We're not giving you any one source. Like we're actually reading these sources and combining like the relevant parts of them, the important parts of them into like a single shorter snippet. So I believe like our advantage over a company like Flipboard would be the more streamlined, like summarized version of the news, that rather than Flipboard, like you still have to like read the articles that they do recommend. They're probably very relevant to you. And I guess it is up to you if you still want to read them. But our differentiation is that we're still generating content that's basically a shorter form of an aggregation of all sorts of articles.
Yeah, I do see an opportunity to mash up the two. I mean, I don't think it's either or.
Yeah.
I do see that, it's a potential for kind of extending an existing product that's out there and it's got a footprint.
Yeah, our team is actually talking a lot about sort of doing something a lot like Flipboard's doing, but like instead of like articles, we'd be generating like text content that you can sort of scroll through that we believe you'd be interested in. So
yeah, sounds good. Good luck to you guys. You guys doing well.
I really like the idea that you shared, that someday you'll have the ability to authenticate with Wall Street Journal or CNN. So my question is, next question, who owns that generated content? Is it like TunedIn versus the source, right? So if you're getting data from a Wall Street Journal or CNN or whatever it is, not going into legal or illegal, but who owns the outcome? Is it TunedIn that owns the outcome or CNN that owns the outcome?
Yeah, so I think to answer that question, when we talk about the podcast as a whole, like we own the information that is in it, or I guess that combination of the information that's in the podcast. When it comes to the individual pieces of the podcast, like for example, bits from CNN or MSNBC or something like that, those pieces of information are cited in our sources. So that's what so that content belongs to them, but since we properly cite it and give them credit for that information, the combination of those sources belongs to us. I hope that answers your question.
Yeah, just going off what Rohan's saying, a lot of AI regulation right now is still like very unclear.
Very unclear.
I think the laws right now say that no AI generated content, like the copyright doesn't belong to anyone. So like even when GPT is like generating some like text, that content doesn't like belong to OpenAI just because there's no like laws and regulations around it. So I think like content wise, it's sort of a free for all for like who owns it.
That's interesting. What is the infrastructure and what is the cost of maintaining your infrastructure right now?
Oh, I can take this one. So right now we are at about 3 cents per podcast. So including like search, script generation, and text to speech. because we're relying heavily on open source models. Back when we were using like API calls and things like that, we were about like 15 cents, which is very, very expensive. Yeah, so we definitely reduce costs. And yeah, so just maintaining that. When we run batch for everyone, we've developed an algorithm basically that we can tell that if you haven't generated a podcast in the last 3 days, then we don't batch your podcast. But we do still send you notifications like reminding you like, hey, check out our app. We still have like podcasts available, press generate for a real-time generation. But yeah, so about 3 cents per podcast.
So how do you plan to like scale it up? Do you plan to bring the cost down even further? If
Oh
it's
yeah.
you're going to, incur a huge amount of cost.
Yeah. So
Still
the more
expensive.
yeah, exactly. So the more we are like, I guess, getting away from API calls to like services hosted by other people, the lower our costs are going. So right now, majority of our cost is actually still spent in text to speech because we are hosting a lot of our stuff on the cloud. And basically, the more users we get, the less it'll go per podcast. Just because we're being charged per hour there, so we'll be able to just churn out more per hour and then kind of just lower costs.
Where are you deploying? Is it Azure, AWS,
Right
somewhere?
now, AWS.
AWS. Okay. Okay, cool. Next, I think we already talked about intellectual property, ethical consideration, misinformation. You talked about hallucinations. What about misinformation? Just slightly different. Hallucination versus misinformation, especially in
Yeah.
the political scenario of like 2024 elections in India or something like that.
Of course, yeah. So when we consider like the quality of information, again, we kind of rely heavily on like major news sources, right? So if Wall Street Journal has an error in it, that's not something we would necessarily catch. But then again, big news sources like Wall Street Journal and especially by taking kind of this holistic approach, right? If you have information from 10 different sources like we do, and you kind of weigh those out together, we can decipher what the common consensus is among multiple sources. So that's how typically one-off errors or maybe one article may have like some fact that's incorrect will get weeded out by kind of looking at many different sources altogether.
Okay, that answers
Yeah.
the question. My
Just like
next
another
question
quick
was
thing. Oh, sorry.
no, go ahead.
I was just gonna add another quick thing. If you were using the app a lot earlier, you would have noticed like a lot of Twitter or a lot of other bad sources. And this was actually an issue we faced. And so like one way we solved this is using source corroboration, like Rohan was saying, and actually avoiding certain sources that we know are not going to be very reliable.
Okay. Have you considered like Apple released, I think Apple released recently an LLM which can be deployed in an iPhone. Have you considered something of that sort where you can deploy an LLM on the app, on the phone, and let it generate content on the phone on the fly, something like that? Is that even a possibility?
I mean, being completely honest, we haven't done too much research into developing on device. And one of the biggest reasons for that is having an LLM run on device. Again, I like, we don't know exactly how much compute this would take up on a phone. We don't know like what Apple's optimizations have been. And also we don't know if like or at least maybe someone in the audience can correct me, but I think the chips that these LLMs are being like ran on are only for later iPhones, or at least the performance is significantly better on later iPhones. And also like running a model on like locally does eat up a lot of compute. And we would want ideally our app to be a bit more lightweight, because like, again, if our app is causing a problem with the rest of the iPhone and like slowing things down, then it could obviously cause problems, because we don't want any negative effect from the user actually like having to deal with any sort of compute related issues related to downloading our app. So again, this is something that, yes, we will definitely do a bit more research into, but that was our initial thought in trying to host on the cloud.
Yeah. What about data privacy? How do I know that my preferences and search criteria are not being shared with others?
Yeah, so currently, when it comes to all this like user data storage, like this is all being done in Google Cloud Platform. So we're using Firebase for our information storage, and we have restrictions on who can access that information and what's available. And typically it's only authenticated materials that can access your information. So
I have so many other questions. We are running out of time. Anyone with last one question?
Yes, I do have one question. Thank you, Ujjwal. Guys, wonderful presentation. Had one question. What is your monetization model?
Yeah, so we have two current pathways that we're considering. Right now, our main objective is to just get as many users on board as possible. But what we are thinking of is first ads. We are looking at about $15 per 1,000 audio listens. So taking that down to like a podcast generation, that'd be 0.015 cent per podcast we could make. So definitely if we drop costs down as well, we would be probably profitable. Another path we're considering is a premium service, which we are hoping to charge around, we're considering different numbers, but right now we're looking at around $2, $1.99. And in this premium service, we'd have like different features like interactive podcasts where you could like speak to the podcast, longer podcasts, no limit on the number of preferences you can have, no ads, things like that. So it's really also dependent on user feedback we get for what features they want. But yeah, so sum it up, premium service and ad revenue.
Okay, thank you.
Anyone with last maybe one more question? No question. Awesome. This was fantastic presentation. Manit and all of you, the friends of Manit, Sumay, Rohan, Varun, and Vansh. And I forgot your name next to Manit.
Sophia.
Sophia. Okay. Thank you so much for taking the time out and educating us with your product. I know it takes a lot of energy and time to do all the research and put everything in one place. So really awesome job. And wish you all
Thanks
the
so much
best.
for the opportunity. Really enjoyed presenting and I really loved the questions and getting the feedback from you all.
I have so many other questions, believe me, but I'll hold it off for the next time. Thank you so
I
much.
think our email was put in the chat, but I can just type it again.
Yeah, I'll put it in LinkedIn also. So just text me. I'll put it in the LinkedIn.
Okay, I'll just do that then. Otherwise,
Yeah.
it's contact@tunedinapp.com. If anyone wants to chat online, we're more than happy to. But thank you so much again.
Okay. Take care, guys. Bye-bye.
thank you.
Thank you.